Hi everyone, I'm going to go ahead and get started with today's lesson on composition of functions. What I'd like you to have in front of you, or what you're going to need to have in front of you, are the notes that we started out with yesterday. So this paper right here, as well as 5.7 notes and homework with the composition of functions. Now, yesterday we got as far as 1A on my side, which is the front side, and 1A, which is your side, on the back side of this paper. Okay, so we're going to be going through those exact same things. So let's go ahead and pick up right where we left off. All right, so we left off with 1B. So I'm going to go ahead and look at this one and identify first. Remember that the f of x equation is radical 2x plus 1. The g of x equation was x minus 4. Now, when we're looking at this, we talked about that the variable closest to x, which in this case is f of x, that's what's going to go on the inside of the g of x function, and the g of x values. So let's go ahead and start with that. So the g of x equation is x minus 4. Now, we also talked about, instead of writing x, we're going to put parentheses there because we know that we're going to plug something into that. Substitute something in. So x minus 4. Now, what are we going to substitute in for x? Well, that's going to be the f of x equation. And the f of x equation is radical 2x plus 1. And that's all under the radical. Okay, so now I'm asking myself, looking at the parentheses, is there anything I can simplify within the parentheses? And there isn't. So in this case, the parentheses are not necessary. So we have radical 2x plus 1, and then minus 4 is on the outside. Now, something that I've noticed is that we want to think that we can take positive 1 minus 4. Unfortunately, or fortunately, whichever it is, we cannot combine positive 1 and negative 4 because positive 1 is on the inside of the radical and negative 4 is on the outside of the radical. So since they're not both underneath the radical or both outside of the radical, we can't combine them. They have to stay left separately. So this is as simplified as it can get. Okay, so that would be our composing one function into the other. Now, to find the domain, we're going to take the radicand, and we need to look back at our table that we created in class. And we said, is 2x plus 1 in the denominator? No, it's not. So we're not going to worry about using where we set the denominator equal to 0. Then is 2x plus 1 underneath the radical? Yes. So when it's underneath the radical, we're going to take the radicand and we're going to set it greater than or equal to 0 so we can find our domain. Okay. So I'm going to take that radicand, 2x plus 1, and set it greater than or equal to 0. Now, we're just going to typically do what we do. We're going to isolate the variable x. So we're going to subtract 1 from both sides. So we have 2x is greater than or equal to negative 1. Then we are going to divide both sides by 2 so that we have x is greater than or equal to negative 1 over 2. Okay. That x is greater than or equal to negative 1 over 2. That helps us with our domain. X can be any number greater than negative 1/2, but cannot be a number less than 1/2. So x could be 0, but x could not be negative 1. And the reason that is because if I put a negative 1 right here, 2 times negative 1 gives me negative 2. Negative 2 plus 1 gives me negative 1. And I cannot take the square root of negative 1. Okay, but now if x was 0, which 0 is bigger than negative 1/2 or larger than negative 1/2, 2 times 0 is 0. 0 plus 1 is 1. And then we can take the square root of 1. So then I could do 1 minus 4. All right, but keep that in mind. That is why we're looking for that domain. That is why that domain is really important to us. Okay. All right, so now I want you to pause the video here. Then I want you to come back, and then I want you to work on problem 2A with me. So right here, you're pausing the video on 1B. You were gonna go work on 1B, and then come back and check your answer. All right, so for 1B, I'm just gonna go ahead and write down the answer, and let's see how you did first off. Okay. And then our domain on this one should be x is greater than or equal to -1/4. Okay. All right, so how did we get that then? Well, I took the g of x equation, which was x plus 3, or parentheses plus 3, and on the inside we put the f of x equation, which is radical for x plus 1, all into the radical. Now, the parentheses have no use for us on this one, so we've got 4x plus 1, and then plus 3 on the outside. To find the domain, I take the radicand, and I set it equal to, or greater than or equal to 0. And we solve for x. So then we will have 4x is greater than or equal to -1, and x is greater than or equal to -1/4. Okay. All right, so now that you've got that down, let's go ahead and go back to the front side. All right, so on these ones here, I'm gonna do 2A, B, and C, and then I'm gonna leave 2A, B, and C for you to do on your own. Once you've done them, go back to Canvas, check that, check your solutions, and see how you did, okay? All right, so let's start with 2A. Well, first off, I'm gonna notice that f of x is 2x plus 5. G of x is x squared minus 4. All right, I'm gonna go ahead and find the domain for each of these. So 2x plus 5. So when I go back to our table, 2x plus 5 is not in the denominator. 2x plus 5 was not under a radical. 2x plus 5 is actually a linear. So when it's linear, the domain is going to be -infinity to +infinity. So for 2x plus 5, the domain is going to pop up as -infinity to +infinity. Okay. All right, now let's go look for x squared minus 4 and see if we can find that domain. X squared minus 4 is not in the denominator. X squared minus 4 is not under the radical. X squared minus 4 is actually a quadratic. So for this one as well, the domain is going to be -infinity to +infinity, which means it can be any value for x that we plug in. All right, so now that we've got that, let's go ahead and work on these problems. So first, I have the f of x equation. The f of x equation is 2x plus 5. So I have 2 parentheses plus 5. And then we are going to substitute in the g of x equation, which is x squared minus 4. Okay, and go ahead and do distribution here. 2 times x squared is 2x squared. 2 times -4 is -8. And then bring down the +5. Combine like terms. So I have 2x squared minus 3. And we are looking at, to find the domain, we're looking at where that x value is. So that x squared minus 4. And that domain is -infinity to +infinity. So our domain can be any value between -infinity to +infinity. Okay? All right, you can pause the video here and then go try 2A, and then come back and watch 2B. All right, let's go on then, and let's do 2B together. 2B, if you want, you can rewrite this as G of f of x. The G of x equation is on the outside. The f of x equation is what's going to be substituted on the inside. So we are going to have x squared minus 4. And the G of x equation is going to be 2x plus 5. All right, now here the square is touching the parentheses. So that means we are going to square what's in the parentheses. And then still have that minus 4 at the end. So we've got 2x plus 5 times 2x plus 5 minus 4. Using distribution, we get 4x squared plus 10x plus 10x plus 25 minus 4. And then we're going to combine like terms to simplify this. So 4x squared plus 20x minus 21. All right, now once we've simplified it, they didn't ask us to solve it, so we don't need to factor it. That is actually as simplified as it can get. That is quadratic. So again, if we're looking at the value on the inside, that there is going to help me find the domain. And the domain that I'm going to be using is negative infinity to positive infinity for this one. All right, I'd like you to pause it here and then go work on 2B on the back side. Then come back and let's do 2C. All right, so for 2C, we have f of x. So that means we're going to have f of x on the outside with the f of x equation also inserted on the inside. So the composite function is going to be only the f of x equation. So we have 2 times x plus 5. And then on the inside, we're also going to have f of x again, which is 2x plus 5. All right, so let's simplify this using distribution. So we've got 4x plus 10, and then plus 5. And that gives us 4x plus 15. All right, that's linear. And either way, I was looking at the part that had the x that was inside. So 2x plus 5, our domain is going to be negative infinity to positive infinity. All right, pause the video there. When you've completed this, oh, don't pause it there, hold on. Finish 2C on the back side of this work page. Once you finish that, go to Canvas, check your answers, check how you did, make sure you understand it, write down any questions you have. If you finish this before the end of class, please work on any missing assignments that you have. That Big Ideas was due today by 3:30. Okay, that work page would get turned in to the pink folder on that shelf on the side of my desk. All right, if you have any questions, feel free to send me a question on Remind, and I will see you all later.